Today I'm going to show you how the oil system works to lubricate your car's engine. Now the main purpose of engine oil is to lubricate and cool off any moving components in the car's engine. I've got an entire V6 engine taken apart here, and we're going to follow the oil circuit from the oil pan through the engine and to the head to see just how the oil lubrication system works. Now we're going to start at the bottom with the lower oil pan. It's just a stamped steel oil pan, and we have a drain plug over here. Now underneath the steel oil pan is the upper oil pan, or the crankcase, and it basically houses the crankshaft inside of here and some lubrication oil, as well as the oil filter. Now this video is going to get a little bit oily, so I'm just going to use my brother's underwear here to clean up all of this oily mess. Next up we have the engine block itself, and it's got these main bearings here that support the crankshaft going down the middle. On the front of the engine we have this oil pump, and that's just driven by the crankshaft here to provide oil pressure. Now on top of the oil pump we also have the oil pickup tube that draws oil from the oil pan. Now engine oil starts its journey from the oil pan, getting sucked up through this pickup tube here. We have a screen filter here that protects it from any large particles getting sucked up in there, like my brother's wedding ring or something, and then it gets sucked into the oil pump over here. Now once the oil flows from the inlet to the outlet of the pump, it then flows back up into the upper oil pan to be filtered, and then it flows back into the block over here. And this is what we have inside. This is where the oil comes from the pickup tube to the low pressure side of the pump. We have these two gears here, with the internal gear having one less tooth than the external gear. On the inlet side here, as this is turning, you can see that the gap is slowly increasing, and then on the outlet side over here you can see that the gap is slowly decreasing, and that's going to squeeze the oil between these teeth of the gear here and pressurize it, pushing it out to the outlet here. Now if there's too much oil pressure built up inside of here, we have a spring-loaded relief valve in here that takes some of that high pressure oil and brings it back out to the inlet side. And if I remove this bolt here, you can see that this is the spring that loads the pressure valve, and then here we have this little valve here which has a little hole in it that allows high pressure oil to escape through it and then back out this passage into the low pressure side. On the upper oil pan, the oil is going to flow up through here, get filtered, and then move down this galley back into the block over here. On the side of the upper oil pan we have the oil filter, but before I do that I'm just going to put down my wife's old shirt here to absorb any of that oil, because this could be really messy. And I'll just prop this up with my wife's old toothbrush. Look at all that oil dripping out of the engine. I guess I won't be able to put this back in her drawer. There's also a drain plug over here. Now down at the bottom here we have the oil pressure switch, and it basically tells the computer that the oil system is doing its job properly, providing enough oil pressure to lubricate all of the components. And we'll just crack this bolt free here, and here we have the oil cooler being removed. You can see it's just like a coolant circuit with this adapter piece here for the oil filter where it screws on. I wonder if the oil cooler is actually optional in some of these, because it seems like an added on piece. So the oil comes at the front here down to the outside part of this filter here. It goes through the oil cooler through this hole here where it exchanges heat with the coolant. It then goes through the oil filter on the outside first, and then exits through the middle here and goes back up to the block. Now I'm going to chop open the oil filter to see what's inside. So here we have the bottom of the oil filter removed. It was just laminated on. Got a freshly stolen sock from my brother's drawer here, then I'm just going to wipe up all this oil inside of here. So how the oil filter works is we've got oil that enters the center here, it then goes through this rubber flap, which is an anti-drain back flap. It then goes through this oil filter material here and then exits out the middle back to the engine. Now at the back here there's the bypass valve. In case the oil filter gets clogged, the oil will then make its way through the bypass valve and then back out the center so that the engine doesn't starve of engine oil. Now I'm going to chop the filter in half to see what's inside. Now the filter is a paper-like material that's been laminated on both sides. You can see this one's in pretty rough shape and hasn't been changed in a while. And there's a closer look at that bypass valve. The filter oil will then enter the block over here and exit back out into the timing cover over here. There's also yet another drain bolt over here. So here we have the timing cover. Now not only is it responsible for enclosing the timing chain and keeping everything well lubricated, but it also has major oil galleys here that feed the engine block and the head. Looking at the back of the cover, the engine oil flows in through here. It goes out to the middle and back into the center of the block. You can see where the oil galleys have been machined out on the timing cover here. The oil enters over here, it goes over to the middle of the block here, but there's also the secondary galley that goes crossway to feed the engine heads at the top here and the timing tensioner. Now not only is the timing tensioner spring activated, but it's also hydraulically activated. We've got this ratcheting mechanism over here, and then on the back here you can see where the oil pressure will come in here and feed into that small hole over there to push this piston out to make sure that there's constant timing tension. The back of the timing tensioner, you can see these are the two holes that feed oil into the engine head for the variable valve timing system. Now coming back to the block here, the oil then enters the center galley, which is the main galley, through the engine block that lubricates all of these bearings. Now looking at this crankshaft bearing, you can see that there's a groove here with these holes in it that brings up oil from this hole over here to lubricate the surface of this crankshaft bearing. Now if I push this wire all the way down this, you can see that it leads to the main galley over here. Looking at the bottom of the block, along where the galley runs, we've also got these sprayers here that take oil from the center galley and spray it on the cylinder walls. Just going to remove this bolt here so we can have a look at that sprayer. And we have the holes on the inside of the sprayer here. Now the crankshaft is not only responsible for lubricating its own main bearings against the block, but it's also responsible for lubricating the connecting rod bearings and the piston wrist pin here. Now the crankshaft and the main bearing here have through holes drilled into them to allow oil to flow through the crankshaft itself despite it being a single piece design. Now this is done by having an oil galley that runs diagonal through these connecting rod bearings and the main bearing here to share the oil. You can see where that was done during manufacturing over here, and they've just pressed in a ball plug. And that is what allows the oil to flow from the main bearing to the connecting rod bearing to allow this to be well lubricated during operation. Now if we follow the trace of oil using these machining marks here, you can see there would be a track along here, then another track going this way for this oil here, and one going across this way, and then the final one being lubricated by that bearing over there. Now while the connecting rod bearing is well lubricated by the crankshaft, there's also this little tiny hole in here that goes up to this sprayer on this connecting rod, and that sprays oil on the bottom of this piston here, lubricating this wrist pin and also cooling the piston head. Now at the top of the piston head, after the two compression rings, we have the oil control ring. Now the oil will collect from the control ring and go into these two holes here that are drilled into the piston head to drain back into the sump. If these holes here are clogged up, it could lead to excessive oil burning because the oil has nowhere else to go. Finally, at the bottom of the block here, we have these oil return passages that bring oil from the engine head back down into the sump to be recycled. Now at the top of the block here, you can see the main oil galley that feeds those main bearings, but we've also got two extra lines that come out here to feed the camshaft bearings in the head. Now you can see how close the oil and coolant actually run to each other. So if you've got a head gasket leak, the oil and the coolant could mix, causing the oil to become a little bit frothy and not really lubricate, and the coolant to not cool as well. Now here we have the engine head. At the top here we have the variable valve timing solenoid, we have the camshaft bearing, and then we have the timing tensioner for the exhaust camshaft. Now engine oil for the VVTi system comes through the timing cover, as we mentioned earlier, through this little hole here, and then it feeds up diagonally into this assembly over here. Now removing the tensioner assembly here, you can see we have this main hole that runs diagonally down to the oil feed over here from the timing cover, and that's what feeds this little filter inside of here that filters out some of the oil before it goes into the VVTi solenoid. Now this hole here is specifically fed by this hole through the timing cover for the VVTi solenoid system only. This additional hole over here that feeds the timing tensioner is actually fed off of an oil galley that runs from end to end on the head here. You can see that these galleys actually continue down the head this way and have been machined down this way, and they just pressed in a ball to block it off at the side here. So the oil essentially kind of travels up around here and then back around this way. Now that side to side galley also feeds these camshaft bearings. We have a hole here, and that draws oil into this camshaft bearing over here. Similarly on this side, as the galley goes down to the next one, we have an additional hole over here that feeds this camshaft bearing here. This little track here is what takes the oil from this hole here to lubricate the exhaust cam, and similarly this oil here is fed through this track to lubricate the intake cam. Now this variable valve timing solenoid controls the amount of oil pressure that flows from the inlet to the outlet and into the variable valve timing gear, so that it can change the timing between the input, which is the outside here from the crankshaft, and the output, which is the camshaft bolted up inside of here. And never mind all these holes, the most important one is the one that comes from the head here, and it goes up to the middle here into the variable valve timing solenoid, across here, and then back down through this hole to go into the variable valve timing gear. Now the camshaft itself is actually hollow, and that allows oil to flow from this cap here from the VVTi solenoid to bring oil into the camshaft and then into the VVTi gear through these holes inside of here to activate it. Now the secondary timing chain tensioner for the chain that goes between the intake and the exhaust side just uses oil pressure that moves from here over to push the piston out against the timing chain. Now the lubrication for the first two bearings are covered by this oil galley here, but then it kind of just stops, and it gets its oil from the engine block, which gets it from the main galley over there. Now the other two camshaft bearings are left to be lubricated only through these little holes inside of here that carry oil through the camshaft. So from the variable valve timing gear to the timing chain tensioner to all of these components here that depend on your engine oil. Now you know why it's so important to change your engine oil to keep your vehicle well maintained. Make sure you follow me on Instagram for more behind the scenes footage, and subscribe for more videos just like this one.